Welcome back, I'm Mrs. Sarah Chen. In this video, we're going to solve the problem of hybridization and VSEPR theory. Let's start. Is there a relation between hybridization and VSEPR theory? Yes, there is a great relation between hybridization and VSEPR theory. Let's start with the meaning of hybridization. Hybridization is one of the concepts that's related to the valence bond theory. Okay, what is the meaning of valence bond theory? It's a theory that explains the formation of the covalent bond. They assume that if you have an orbital which has a single electron and another atom has an orbital which have a single electron, for an example hydrogen atoms, so they can overlap together or intersect to form an orbital which has two electrons. Here is the covalent bond. So here, after the overlap concept, they face a problem with the carbon atom. Let's start to make the configuration for the carbon atom, which is 6, will be 1 S2, 2 S2, 2 B2. Let's draw the P sublevel here. It has 3 orbitals, but it has only 2 electrons, so 1 and 2. Okay, here the carbon atom just can make how many covalent bonds? They can only make 2 covalent bonds, while this one and also this one. Why is that? Because they have no other orbitals which have a single electron. Okay, after that they assume that there is a phenomenon which is occurring to the carbon atoms, which is called hybridization. Okay, what is the meaning of VSEPR theory? VSEPR theory means what? Means that the geometrical shape of the molecule must be at the minimum amount of the repulsion force. Okay, VSEPR is an abbreviation for what? Is an abbreviation for valence shell electron pair repulsion theory. So it considered the geometrical shape for molecules from the minimum amount of repulsion between what? Between the atoms forming the molecules. So here, let's start about the relation between hybridization and VSEPR theory. But first, you should know the difference between sigma and pi bond. Let's consider the comparison or the difference between sigma and pi bonds. Sigma and pi bonds are covalent bonds, so they are formed due to the sharing of electrons or overlapping of electrons. We have 2 types of overlapping. The orbitals may overlap head to head as this shape, so it will be sigma, while if they overlap side by side as a parallel or collateral overlap, so it will be a pi bond. The second point, which is very important here, is that sigma bond is occurring between the pure or hybrid orbitals or hybrid and hybrid orbitals. The pure orbital, this is the orbital that didn't undergo any hybridization reaction, while the hybrid orbital, this is the orbital which undergo a hybridization reaction. So what about the pi? Pi occurs only between the pure and pure orbitals only. Okay, which one is the strongest one? Sigma, of course, is stronger than the pi, which is weaker than sigma. Okay, let's consider and don't forget that single bond or single covalent bond only contains sigma, while double covalent bond contains 1 sigma and 1 pi. Triple covalent bonds contain 1 sigma, which is the basic bond here, and 2 pi bonds. Okay. One more thing that you should know before reaching to the type of hybridization is the type of the electron pairs. How many types of electron pairs do we have? We have only 2 types. The first one is called bond pair, the second one is lone pair. What is the meaning of bond pair? They are the electrons that share in the bond formation. The lone pair, they are the electrons that don't or doesn't share in the bond formation. For an example, for the ammonia molecule, first we have to make a configuration to the nitrogen and the hydrogen. Nitrogen, its atomic number is 7, so it will be 2, 5, while hydrogen is only 1, so it will be 1. Okay, let's draw the Lewis structure. To know more about Lewis structure, just follow my videos. Okay, nitrogen here has only 5 I will take the valence electrons only. So you have to draw 5 electrons. 1, 2, 3, 4, and 5. Okay. Why I draw single electrons? To be able to share with the hydrogen atoms. Okay. So here, these 3 electrons that share with hydrogen atom are called bond pairs, while the 2 electrons that don't share in the formation of the bonds, that don't form any bonds, they are called the lone pair. Now, we should start to know more about hybridization and VSEPR theory. So don't forget that you just need to count the number of sigma bonds and lone pairs to know what? To know first the type of hybridization, second the geometrical shape or the stereostructure of the molecule, and third the bond angle. Okay, what about our rules? It's too simple. You just count the sigma and lone pair. If the sigma plus lone are equal to 4, so the type of hybridization will be sp3. Okay, if you have 4 sigma, so your shape will be tetrahedron and your angle will be 109.5 degrees. Okay, while if you have 3 sigma plus 1 lone, so your shape will be 3 base pyramid and the angle will be 107 degrees. Okay, what about if we have 2 sigma plus 2 lone? Okay, here the shape will be angular shape, or the stereostructure will be angular or vent or V-shaped, which has an angle of 105 degrees. Okay, what about if we have the summation of sigma and lone equal 3? So the type of hybridization here will be sp2. So this sp2, if we have 3 sigma, so the shape will be planar triangle, which has an angle 120 degrees. If we have 2 sigma plus 1 lone, so the shape will be angular or vent shape with an angle of 119 degrees. Okay, what about if we have the summation of sigma plus lone equal 2? So we have a type of hybridization which is sb, which has only one case, that we have only 2 sigma, so the shape will be linear and the angle will be 180 degrees. Okay dears, it's time to practice. Let's start with our first example here, the beryllium fluoride. Okay, just you need to know that beryllium has 4 electrons, so its configuration 1s2, 2s2. Okay, so it has how many valence electron? Has 2 valence electron. Beryllium is the central atom because it has the least number of atoms in the molecule, so it will be in the center, has only 2 electrons, 1, 2. It connects with 2 fluorines, so here 1 and 2. Here, is there any lone pair of electron? No, just sigma bonds. How many sigma? 1 and 2. So here we have total number of 2 sigma. Let's remember 2 sigma. What is the type of hybridization? It has 2 orbitals only, so 1s and 1b, sb. Great, sb. Okay, what is the shape of sb? SB has a linear shape with an angle of 180 degrees. Great. The next example, CH4 or the methane molecule. We just need also to know that it's C bonds with H. How is that? C is C6. So 1s2, 2s2, 2b2, so it has 4 valence electrons. Okay, so from this 4 valence electron, just you need to count the sigma bonds or the lone. It doesn't have any lone, so you just count the sigma 1, 2, 3, and 4. So it has 4 sigma. Let's remember the 4 sigma means that we have 1 S and 3 from B, so B3. Okay, SB3. Okay, if we have 4 sigma, so the shape will be tetrahedron with an angle of 109.5 degrees. Okay, The next example, SO2. Okay, SO2, the S has 16. So let's make a configuration for it. 1s2, 2s2, 2p6. Now it's 10. 3s2, 3p4. So it has how many valence electrons? It has 6 valence electrons. So S is here. Okay, it connects with oxygen. So here oxygen has to bind with a double bond. So here double bond with O and another double bond with O. Okay, how many electrons did we use? 1, 2, 3, 4. So we still have 2 electrons, which will be lone pair. Okay, so here we have a 1 lone pair. Okay, let's start to count our sigma. Here the double bond, we said that we have 1 sigma and 1 pi. Okay, we need only the sigma pi. So here we have 2 sigma plus 1 lone. So the total will be 3, right? Okay, 3 means that we have sp2. Okay, let's consider the angle and the shape. If we have a 3 or sp2 hybridization with 2 sigma and 1 lone, it will be what? It will be angular. Okay, angular with an angle of 119 degrees. Okay, for our last examples here for this video, the water, the O will be 8, so 1s2, 2s2, 2b4, which gives us the 8 electrons. So it has 6 electrons, 6 valence electrons. The O here has the least number of atoms, so it will be the central atom, O. Shares with 2 electrons to bind with the hydrogen here and the hydrogen here. So it has 6 electrons, it shares only with 2, so it has 4 electrons, which means 2 pairs of lone electrons. So here just we need to count the sigma and the lone pair. We have sigma, sigma, lone, lone. So we have 2 sigma plus 2 lone, which give us 4, right? The summation of the total of 4, which give us the type of hybridization SB3. Okay, with 2 sigma and 2 lone, the shape will be angular with an angle of 105 degrees. Okay, the next example, C. We just said in the previous example that C has 4 valence electron and O must bind with a double bond. So here O and here O. Let's count the sigma. Okay, we have here sigma pi. We said that the double bond has 1 sigma and 1 pi. So here we have how many sigma? 2 sigma, which give us the hybridization SB with a linear shape and angle of 180 degrees. Okay, the next example, C2H4. The C is the central, like that. H, and H. Here we have how many carbon atoms? We have 2 carbon atoms. You can't know the type of hybridization from all these carbon atoms. You just need to choose 1 carbon atom. So I'm gonna choose this one and start to count for it the sigma and lone. Okay, here sigma, sigma, sigma and pi. We said that we don't need pi bond, so we have 3 sigma, which give us SB2 with a planar triangle shape and angle of 120 degrees. Okay, the last example is the ethyl or acetylene, which has this composition. Okay, let's start. We said that the triple bond, I'm going to choose also this C. We said that triple bond has only 1 sigma and 2 pi. So here we have 2 sigma with hybridization of Sp, which give us the linear shape with an angle of 180 degrees. At the end, I want to thank all of you for watching my video. Don't forget to like, share and subscribe in my channel to get more videos. See you!